So we have three charges here. Charge 1, charge 2, and charge 3. Charge 1 and charge 1 and charge 3, they're fixed in place, and charge 2 is free to move. Charge 2 will move depending on the force that's exerted on charge 2 from charge 1 and charge 3. Now charge 1 is positively charged. Charge 2 is negatively charged, and charge 3 is negatively charged. The first thing we do in this kind of a question is we draw the force vectors. And the idea is that we want to find the net force on charge 2. So you want to find the forces on charge 2. So between charge 1 and charge 2, they're opposite in charge. So they attract. So the vector on charge 2 is going to point in the positive y-axis. And this is the force from charge 1 onto charge 2. As for charge 3, it's negatively charged, and when we have two negative charges, they repel. So from charge 2's point of view, charge 3 is pushing it away. So in the negative x direction. Now that we've drawn the force vectors, the first step in this problem is to find the magnitudes of each of these forces. So that's the force on charge 2 from charge 3. That is the force from charge 1 onto charge 2. So we always start by finding magnitudes of the forces. So when I take the magnitude of this equation, the signs of the charges become positive. So in this scenario we have K, we have charge 1 and charge 2. And our radius, or our distance between charge 1 and charge 2 is d, which is known as this number that I've circled. So we write d squared. The next step is to plug in the numbers and the units. So we have 9 times 10 to the 9, that's the K, Newton meter squared per Coulomb squared. Then we have charge 1, which is 2 times the fundamental charge. And then we have charge 2, which is negative 3 times the fundamental charge. But remember, since we're taking the magnitude, that negative sign disappears. So that's charge 1, and that is charge 2, divided by d squared. I haven't plugged in all the numbers on purpose. Now I'll do that. Before I continue though, when you have this situation, you can multiply the 3 and the 2 together and multiply the two fundamental constants together so they become e squared. That's something to be careful of when you plug things into your calculator. And our fundamental constant is this 1.602 times 10 to the negative 19 coulombs. And again, don't forget the squared. And then the distance between these two charges was 2 times 10 to the negative 7 meters. And now I'll plug this in my calculator. So sorry, I made a mistake. When I multiply the 3 and the 2 together, it becomes 6, not 5. Not 5. And I also forgot the squared sign, so I just put the 2 here. And the answer I get for the magnitude of the force from charge 1 onto charge 2, which is 3.46 times 10 to the power negative 14. So now that we have the magnitude of force 1, we already have the direction because we drew the vector. The direction is in the positive y-axis. So you could write this in unit vector notation like this. So j hat. Now we do the same for force 3. Again, remember, we're working with magnitude, so the signs of these two charges become positive. And we do 5 times 3, which is 15, times e squared, because we were doing 3e times 5e. So when we multiply the e's together, it becomes e squared. And e is known to be 1.602 times 10 to the negative 19 coulombs. And again, don't forget the squared. And we divide this by the distance between charge 2 and charge 3. This time the distance will be 2d. So it's 2 times 10 to the negative 7 meters, all squared. And I'll plug this in my calculator. And now force 3, the magnitude of force 3, I found it to be 2.165, or 2.17, I'll round it up to, times 10 to the negative 14 newtons. Now again for force 3, since we drew the vector already, we know the direction. So now that we have the magnitude, the direction is basically in the negative I hat direction. So basically the net force on charge 2 is written as follows. Again, I factored out the times 10 to the negative 14, so I don't have to write it twice and make the answer lengthy. So basically, what we're saying is that the net force on charge 2 is pointed in this direction, with F3 and F1 as X and Y components. I hope this helps.